In this question, we've been given two heavenly bodies, the Earth and the Moon. The question says if a person weighs 750 Newton on the Earth, which means W to the base E is equal to 750 Newton. Now the question says what would his weight be on the Moon given that Moon's mass is 1 by 81 times of that of the Earth. That means if this person actually goes onto the Moon, what would his weight be? This is what is asked in the question. So we'll write everything in the given data, and from the given data numerical becomes absolutely simple. So in the given data, first of all, W to the base E is 750 Newton. We also know that Moon's mass is 1 by 81 times that of the Earth. That means m to the base m, that is Moon's mass, is equal to 1 by 81, that is 1 upon 81, times that of the Earth, that is m to the base e. So we shift m to the base e below m to the base m. So we get mm upon me is equal to 1 upon 81. Now the question also says that radius is 1 upon 3.7 times. So r to the base m is equal to 1 upon 3.7 times r to the base e. Again, what do we need to do? Shift re below rm. So we have rm upon re is equal to 1 upon 3.7. What do we have to find? We have to find the weight on the Moon, that is W to the base m. Which formula are we supposed to use? We know that W is equal to F, that is weight is nothing but the force, which is capital G, capital M, small m upon capital R square. So we write the same formula in the formula section. Now this formula is a general formula, but we have to write two formulae, one for Earth and the other for Moon. So for the Earth we will use a subscript E, for Moon we use the subscript M. So first we'll make a formula for Earth. Now we know that G is a constant and m, that is small m, is a constant because mass of the object does not change from place to place. So m, small m, and capital G remains as it is. So we have capital G me into small m upon re square. This is equation number 1 for the Earth. Now we have to make one for the Moon. To make one for the Moon, instead of W to the base E, we write W to the base m, and rest in place of E, we just need to substitute m. So we get this formula for Moon. This is equation number 2. Now we know we have to divide these two equations. So when we divide these two equations, we have Wm upon We is equal to this entire term. So we write this entire term. Now division obviously becomes multiplication, so we can take the reciprocal of this term, right? So when we take the reciprocal of this term, we get re square upon Gme into m, right? Now capital G gets cancelled and small m gets cancelled. Now what I do is I write this as it is, but instead of mm upon rm square, I bring me to this side. So I get mm upon me into re square upon rm square, but which can be written as the whole square. Now we have Wm upon We is equal to mm upon me. Now what we should understand over here is that mm upon me is 1 upon 81, right? Now since this is 1 upon 81 and re upon rm needs to be found, but here we have rm upon re. Now since we have rm upon re, we have to take a reciprocal. That means 1 upon 3.7 becomes 3.7 the whole square. Just take the square of 3.7. So Wm upon We is 750 in the given data. 1 upon 81 remains as it is. 3.7 square is nothing but 13.69 upon 81. Shift 750 to the right hand side. So we get Wm is equal to 13.69 into 750 upon 81. Now we start calculating this. So here what we get is 3 into 27 is 81 and 3 into 250 is 750. Now again if you see over here, if we calculate this, we get 9 3s are, and over here what we obtain is 1.52. Again we try and calculate, that is 3 1s are 3, and the answer that we obtain over here is 0.507. And then when we multiply both of them, the answer that we obtain is 126.8 Newton. So the answer is weight on the Moon is 126.8 Newton.